Good afternoon, and welcome to our fifth and penultimate Fireside Chat, fueled by Holland Company and produced by Plastics News. I'm Plastics News Conference Director Joe Pryweller. We are proud to bring you this streaming event where you'll hear live, casual conversations with leading experts on a variety of significant topics to the plastics industry. Today we are broadcasting this event live via YouTube from downtown Chicago, and you will have the opportunity to ask questions in real time and receive on-air responses. To participate in this live chat, you must have a Google account with an associated YouTube channel. If you do not have a Google account, you can either create one or add a YouTube channel to an existing account. You can type questions in the live chat box to the right of your screen at any time during the chat. Today's chat will explore many of the major developments in flexible packaging, a dynamic area of plastics that is affected by key technology shifts, sustainability, food packaging and consumer trends, resin expansion, and much more. We'll take a deep dive into these key issues affecting this market and those producing packaging film and sheet. We have with us a blue ribbon group of flexible packaging experts. First, I'd like to introduce Rudy Bourgeois, Vice President for Film Development at the Holland Company, one of North America's largest plastics resin distributors. Joining Rudy today will be Joel Longstreth, Marketing Manager of Brentwood Plastics, a 54-year-old specialty manufacturer of custom blown films, and Dan Falla, Technical Services Specialist at Nova Chemicals and an expert in polyethylene for packaging film. Before we launch into this discussion, all of us want to express our sympathies for those affected by the hurricanes that have devastated many communities over the past few weeks. Our thoughts go out to you, and we wish you speedy recovery for your homes and businesses. During this fireside chat, we will not be commenting on supply or pricing issues or short-term effects from the hurricane. There are a number of publications addressing these questions already. Allow me now to turn the conversation over to Rudy Bourgeois of the Holland Company to kick things off. Rudy, take it away.
Thank you, Joe. And Dan and Joel, I really appreciate you being here. I know you're taking time out of your busy schedules and made your way here to beautiful Chicago area. Today we'd like to talk about flexible packaging and the advancements around the flexible packaging industry. And I guess a good place to start is resin supply. Resin accounts to about 60 to 70% of the cost of flexible packaging. So I think this is an important area in which to start. There's been announcements in the industry of upwards of 18 billion pounds of new capacity that's coming on stream currently and through 2020 and beyond. What, in your opinion, has sparked this tremendous growth in new resin capacity?
Like it or not, I think it's fracking. Fracking has increased the supply of natural gas. It's also made the U.S. the least cost producer. If you think about it, we put our plants right smack dab on top of where the gas comes out of the ground. We don't have to transport the monomer, and we don't have to buy spot. We buy contract, so that means that we are the lowest cost producer. People that I've talked to in the majors do consider export to be anywhere from 25 to 33% of where they expect to sell the resin.
And there's lots of demand for it too. We see continued increase in demand. I know my specialty in the focus area at Nova Chemicals is to focus on food packaging and the enhancements that we can provide to the marketplace for longer term shelf life for products out in the marketplace, and the continued emphasis on there. So the supply and the supply is definitely needed.
That's excellent. I know by 2020 there's announcements of 18 plus billion pounds. The last 2 or 3 years we've seen utilization rates about 93%, and according to the forecast from the people who do the forecasts, when we get to that additional 18 billion pounds, we're still going to be up in that 87–88% utilization rate. How do you account for that? That's significant growth without losing a lot of utilization rate.
You know, that's not a great strength of mine. What I'd really like to suggest you do is there's lots of information out there. Chris Gick, if you know Nova Chemicals at all, he's a great economist, and And if you go and search his name, he's spoken at a number of different conferences that can really address those types of questions. Again, back to my area of expertise is in the food packaging area and the continued expansion, trying to find solutions to existing problems that are out there to further enhance the way of life in North America.
Okay. Metallocene has really come into play over the last 20, 25 years, which is kind of the most exciting advancement in polyethylenes. Where do you see metallocene continuing in its growth pattern?
I think it's very important. And back in the 1990s, the resin companies told us that it was going to be the Holy Grail. I don't think there was any question that they were right. I think there's a big misperception about metallocene that we need to clear up right away, and that is that metallocene is a catalyst. It is not a comonomer like octene or hexene or butene. And when people have a problem with their packaging, they say, well, we should throw more metallocene into it. That's really an oversimplification, because the higher density you have of a metallocene, the stiffer and more difficult it is going to be to melt, vis-a-vis in the lower densities, say below 900, where it's a soft, very easy to melt, good hot tack resin. So it's not immune to the laws of density. So the cool thing about metallocene is that it enables the polymer scientist to create uniform cookie cutter molecules without a lot of side chain branching and what I call junk. So it allows you to make really very specific properties. Now, we've probably tried 17 metallocenes and we haven't met one that we don't like. It's just a matter of pairing. Like you wouldn't put Sauterne with an appetizer course. Well, you wouldn't have a higher density metallocene with something that you want to have a fast seal initiation.
And I'd like to add to that. If you look back, there's really been no great new polymer development since the early 1990s. That's the single site, the CGCT, the metallocene, different types of polymers that have been out in the marketplace. But what happened at that time when those polymers were developed, and I agree with you, every molecule is the same as every other molecule. They're very hard to process. A lot of amps, a lot of back pressure. It took a lot of energy to process those. The equipment at that time didn't really match up to being able to process them very effectively. So we've been working, and me in particular, with Nova and other equipment manufacturers, have been working together to try to develop better extrusion systems that can handle the processing of those resins more effectively. It has led to multi-layer co-extrusion, where now standard state-of-the-art is 5-layer co-extrusion. If you get into barrier meat packaging and cheese, etc., the state-of-the-art is now 9 or 11 layers. So the metallocene resins, I agree with you, they have very niche market type of things. They're all very good. Some process different than other ones. But the equipment, it was very important to be working in conjunction with the equipment manufacturers to have those kind of products so that we could bring a solution to the marketplace.
Yeah, and it was critical and it was very successful too, because metallocene is used in just about every aspect or every application within the flexible packaging industry. We'll talk a little bit more about that a little later on when we talk about the specific advancements in flexible packaging. I'd like to just transition now about this feedstock perception. We have gas out of the ground, and we have green ethylene, so to speak, made from corn, made from sugar cane. How do you see that growing as we move forward with feedstocks?
I think it's a matter of perception. It's perceived that ethylene that's derived from a plant source is better or greener than ethylene that's derived from evil fossil fuels. But as you said earlier, ethylene is ethylene, and it's just a matter of where you get it. The major food companies are now looking for what they call Gen 3. Gen 1 is conventional polyethylene and polypropylenes. Gen 2, they were all looking at plant-based. They've seen what's happened to their major costs because of ethanol. If we start making bazillions of pounds of plastic out of agricultural sources, well, their costs are going to go up. So that's why they're taking a step back and saying that the jury's not out. They want to see what Gen 3, whatever that is, will look like, and nobody really knows what that's going to be, but we do have a perception problem as far as any kind of plastics being derived from fossil fuels.
Okay. From a supplier perspective, do you have a feel, costing-wise, less expensive out of the ground, less expensive from the green fields?
Well, you know, that's a very good question. And I think we have to really take a look at the circular economy and how that whole concept fits into the circular economy. And what I mean by the circular economy is it used to be called cradle to grave or cradle to cradle. There's a number of different terminologies that really fit with that. So how, once it's used and it's put out into the market, how is it effectively used? Oh, the other one I wanted to add to that was it came from a fuel source, so why can't we use it as a fuel source? So waste energy is another concept of that. There's some really good examples out in the marketplace where the circular economy has turned out to be very, very effective. I'll use an example of one particular company that I'm familiar with. Now, my expertise is in polyethylene, but this particular company their expertise is in PET water bottles. The company's Ice River Springs, and they're located just north of Toronto. They have an infrastructure that's set up that they can take virtually all of the recycled, all the blue box PET that goes into the blue box, take it back into their plant from Ontario and the northern part of New York State, bring it back into their plant, clean it such that at the state that it's suitable for direct food applications again, turn it back into water bottles again, and put it back out into the system. So that's a total circular economy. They manufacture water, they don't manufacture the water, they manufacture the water bottles, they distribute it out to the marketplace through our Blue Box program that's very prevalent across the Canadian market segment. They take it back in, they clean it up, repackage it in water, and ship it back out again. So it just keeps going around and around.
Dow has embarked on something that is even more crazy ambitious than that. They're thinking in terms of taking flexible packaging. If you think about it, it's already been refined, and they're trying to make monomer out of it again. They've got some pilot plants going up, but if they could pull that off, that would be very cool. That would be a true cradle to cradle.
Yeah, that would. I've been into a plant that does compression molding, and they take all of the recycled material that's picked up by the waste companies, and he actually pulverizes them with very, very high RPM blades, and it crunches everything up, and it's indiscriminate. There's polyethylene, low density, linear low, high density, there's polypropylene of all sorts, there's PET, there's styrene, all of the different plastics. He throws it in there indiscriminately, and with the high speed RPM blades, it crunches everything up, and it actually produces little bricks of polymer, and they have different compression molding molds that make different products, and they know how many bricks to throw into a particular thing. And what that product goes into, it goes into anti-fatigue mats. You see when they do road work, they have the orange barrels and they have the little black ring around that to keep it on the ground. That's where that material goes. And so it's the ability to use any of the different plastics, grind it up, compression mold it, and give it new life.
But there's a lot of need for similar types of polymers to be used. For example, one of the biggest wants and desires, or one of the biggest growth areas in North America right now is the stand-up pouch. I know from our corporation we've taken a very strong leadership role in the development of the all polyethylene stand-up pouch. And the concept here is a lot of stand-up pouches right now have reverse printed PET. You need the high graphics, you need the very good gloss on the surface. So we've developed technology with the all polyethylene stand-up pouch where we can deliver that to the consumer right now. And if you watch what's going to happen over the next few weeks, you'll also probably see some announcements related to some special recognition coming in that area, in that we've been able to develop an all recyclable as polyethylene pouch that has oxygen barrier properties to it. And that's a huge leap into the sustainability market in order to be able to supply products that can be recycled as a single polymer.
Yeah, that's very important. Go ahead.
No, I was going to say it's one of those deals where 1 + 1 = 3. If you take the high densities that you guys have developed, which are so high in density and they're very stiff, that's where you get your barrier properties. You don't need PVDC, you don't need EVOH, and you have other metallocenes in the sealing layer. Now you take that and couple that with, say, either surface print or even digital printing, then everything in that pouch, the zipper, the sealant layers, the outer layer, it's all polyethylene. And it can go number 2, it can go number 4. It doesn't really matter.
Yeah, we've had a lot of feedback from downstream customers, from the end users, a lot of interest internally as to how these products are going to work. And you'll see a lot of changes coming in the marketplace in the very near future.
Right, because it's not a 7, it becomes a 4 or a 2.
Absolutely.
That's the beauty part.
Right. And then when you go to the grocery stores, what do you see on your shelves more and more frequently, is not the cans, but the stand-up pouches. They have a lot more consumer appeal because of the high print quality that's on there. They stand up, so you have more effective utilization of the store shelf. And I think that's a major push in the industry, is the stand-up pouch. And then within that industry, doing the all polyethylene or all polypropylene or all similar material is the next generation of stand-up pouches, so that it can be totally recyclable.
Is it, if I can interrupt, can that work with co-extruded material too, if you need something for a better barrier, or is that where the issue lies with monomaterials?
Well, you know, I'll answer that question. We've been doing a lot of work with the equipment manufacturers with regard to co-extrusion. Today, there's anywhere between 5,000 to 6,000 extrusion lines in North America, and those are predominantly monolayer, maybe 60% are monolayer. But what we've seen since the mid-90s is a dramatic increase in the number of co-extrusion lines. Today, as I said earlier, the state-of-the-art is 5-layer co-extrusion. And there's a tremendous amount of demonstration that's been out there that by using a 5-layer co-extruded line, you can replace a number of monolayer lines because of the advancements that the equipment manufacturers have made. You reduce down the gauge variation, and we've talked about gauge variation quite a bit in the past. You might have a plus or minus 10% gauge variation in production with an older line, but with these brand new lines that the OEMs are coming out with, we're looking at plus or minus 2 or 3%. That's a dramatic savings in their pocket. We also talked about the 5-layer. By engineering which resin goes into which layer, you can design in the end-use physical properties. There's a phenomenon that's called the I-beam effect. And with the I-beam effect, you can make a product appear and feel stiffer by where you place the resins in that structure. For example, we talked, you had mentioned about the high barrier. We have a high barrier, high density, so it's a high moisture barrier, high density polyethylene. It's also higher in density. If you spread it out in a 5-layer structure as far as possible, you dramatically increase the bending stiffness of that film. That's really important for down gauging, for sustainability. You can then run that film faster through a form, fill, and seal line when you've down gauged it, because it is now stiffer. You need the stiffer materials to run through it. Now, we also talked about the other barrier properties. State-of-the-art for blown film in food packaging for barrier is now 11 layers. And there's a lot of different things you could do with the 11 layers. You incorporate nylon into it, EVOH, the EVOH for the barrier properties, nylon for thermoformability as well as other physical properties. You have the single site resins that can be used in the sealant layer. So every single layer in that 11-layer structure is designed for a specific reason.
Good.
Another aspect of that is, no pun intended, but a barrier to down gauging is marketing's perception of what they think the consumer's perception is going to be. I've personally given up on trying to down gauge, and that's because they say, oh, well, we understand the savings and the performance is exactly the same, but we don't want to take the chance that the consumer is going to think that we've cheaped it out. And it's a perception thing that the stiffer something is, the more it feels thicker. Right. And so what you're saying is that by making it stiffer.
By using the I-beam effect, you separate it out, and you, in fact, there's a conference that's coming up in about a month from now in Naples, and last I heard from the hotel, things are in pretty good shape. FlexPackCon being held in conjunction with AmCal, and I'm doing a paper at that particular conference looking at that, and I will be presenting the I-beam effect. And this is part of a poultry investigation that we did. One of the jobs that I do at Nova is I like to go into a market segment and channel down and dig down and find out what's the future, where are things going in the packaging market, so that we can anticipate what the consumer wants, so that we can have the polymers and the structures ready to be available. So that study that I'm going to present at this particular conference is a deep dive into the protein packaging market segment. From that, we identified that chicken is the highest growth segment in the food packaging market for consumption in the United States. And what we determined that the typical way we buy chicken breasts right now is in that foam polystyrene tray that's overwrapped. You bring it home, you open it up, you take a couple breasts out. Well, today's millennials really don't want that, and most consumers don't want that. You got to get in there with that goopy mess with the chicken juice. You take out the few breasts that you need, then you got to do something with those 4 breasts or 3 breasts that are left over now. So what this deep dive into that market segment has done has found a new application for a new kind of product. So we're predicting that the next evolution in this market segment is probably going to be the portion pack. And that's where you take the individual chicken breast through a thermoform process, you package it such that each individual breast is packaged, and you bring it home. It's in a clear package. You don't have to touch the juices. You take whatever you need, whatever's left over, you throw it in the freezer. It's a sustainability side. And during the conversations we've had, the food waste is just phenomenal.
That leads us into the food waste, because I've been to several conferences over the last couple of years, and consistently the speakers at those conferences are saying about 30 to 38% of the foods that are generated go to waste. They go to waste because people put too much on the table, and then they throw the rest of it away. And the rest of the foodstuffs is because food in packages go beyond their extended use by date, and they end up getting thrown away. So the flexible packaging really is critical in extending that shelf life of foodstuff, so that we can consume that extra 30% of the food that's prepared for human consumption.
And you get people that laugh at the cucumber because you have the plastic wrap on the cucumber, and well, it's already got a skin on it. What do you need a plastic? But actually, it maximizes the shelf life of that product because of that overwrap. Now, another example of where this is really becoming important is the meal delivery kits. Now we're seeing a big explosion in meal delivery kits. And one of the reasons for that is because, as silly as it sounds, it actually reduces the amount of waste that's going to landfill, because you're being delivered what you need for that meal. I know myself, with my partner that I live with, when she goes out grocery shopping, may bring back a whole pile of stuff that we're going to make dinner with. We're not going to use all of that, and unfortunately it ends up getting spoiled and we can't consume it. So these meal delivery kits are really addressing that situation. They're actually reducing the amount of waste that's being generated.
How does that impact flexible packaging? We're talking about Blue Apron, Uber Eats, some of those companies, and also portion packs. We're talking about packaging things in smaller packaging. Does that impact the manufacturing end with either blown film or other kind of flexible packaging that you're doing, as far as the structure goes, or the type of manufacturing you're doing?
It's really created some challenges in terms of structure design, so that you can get the thinnest film possible while still getting the barrier properties, getting the demands. It needs the clarity, it needs the safety, it needs the packaging speed. There's a lot of attributes to it.
The hermetic seal. There's a lot of performance requirements that go into the different packages, as well as the extended shelf life component. And that speaks to the technology of how you put the resins together, in what combinations and at what gauge to deliver all of those criteria.
It's just amazing how much this industry has changed in the last 5 to 7 years. It's just amazing. And that's just the start as to what's going to come.
Exactly. I remember back in the 70s when I got into the plastics industry, linear low was coming out at the time, and the prediction was that linear low in another 10 or 15 years is going to completely obsolete low density. Well, that never happened, but it has become the predominant resin today in flexible packaging, and it accounts for almost 50%. Low density and high density account for just under 20% each. polypropylene about 8%, and then the other exotic resins like the nylons, the PETs, the EVOHs, the tie layers account for the rest. So linear has definitely come. But I remember back in the old days, we had extruders made for running low density, at lower horsepower and narrower die gaps, and we had to open up the die gaps, and we had to put 2.5 times bigger horsepower on the extruders to go. But today, all of that has advanced to the point where you could be 100% linear outlet on the extrusion equipment because it handles it so well.
Yeah, we've been doing a lot of work in designing resins specifically to meet that. Now the equipment manufacturers have gone so far above what resin capabilities are. We've done a lot of work in the last couple years to design resins to keep up with the equipment. And we're doing this in conjunction with the major equipment manufacturers with trials we've been doing in Germany and other parts of the world. And we're now able to get up to the speeds that those pieces of equipment are running by the molecular engineering of the new polymers that you're starting to see out in the marketplace. High speed, high melt strength, high clarity types of polymers. Big changes.
There are a lot of big changes. I think that's really important for the major markets that bigger companies go after. There are smaller companies that go after more niche markets, less about output rate, more about functionality and performance and cost effectiveness. So I still see that there's a real good utilization for the low density equipment that's out. I go to a lot of places and a lot of people will say, they almost apologize to me before we go out and do a trial that they have old equipment. And my comment back to them is, old equipment does not necessarily a bad thing as long as you maintain it. You maintain it, that thing will last you for decades.
And they do.
And they do last for decades.
There's, as I said before, there's between 5,000 and 6,000 blown film lines in North America today, and by far the majority of those are monolayer, old monolayer. Yeah, they last forever.
Yeah, but there's good and there's bad in that. Good and not optimum. In that it's not bad, it's just not optimum. I know when we help people as they want to grow and expand their capacities, and they have conversations with us about what type of equipment they should get, our response first and foremost is, what do you want to do? What markets do you want to go after? And what are the requirements of that? How big or how small is your lay flat? Give me the parameters of what you're looking at, because sometimes it's buying one of the big lines, the $2 to $4 million lines that pump out 1,800 pounds an hour, give you a gauge variation within 2%, and that's great if you're going after big markets. But if your marketing strategy is to going after small niche areas, then that's the wrong kind of equipment to buy. You're wasting money and you're putting yourself in a real negative cash situation, whereas buying smaller, lower output and a lot less expensive extruders like $70,000, $80,000 that pump out maybe 90 to 150 pounds an hour, you can have 3 or 4 or 5 of those and run 1 or 2 products on that and really get some efficiencies. But it depends on what market you go after.
But you got to take into account what some of these major equipment manufacturers are doing today. They don't necessarily have to have that great big line, but they've improved things so much that their type changes are down to minutes. Like, I'm not talking 5, 10, 15 minutes, slightly longer than that, but they can change film types very quickly now. The computer technologies evolve so much and the blending technologies evolve so much that they can respond to the smaller demand applications. But I do agree with you that when you get into some of the more specialty niche markets, some of those 10, 9, 10, 8, 10 inch dies might be a little bit too big for them.
So are you saying that nylon and things like EVOH, they can clear that out in 15 minutes?
Well, that's what they're saying. We'll have to.
I'll give you a case in point. I was at a place, they had 4 mono lines, and they bought a coax line with all of the bells and whistles, automatic changeover, everything. And we were running a dunnage bag trial, which is, it's 5 to 8 mils depending on what sizes you're going after. and they were running a 3-layer coax line. They were running linear low octane and some low density on those through those 3 layers. And we put the polypropylene because in these dunnage bags, and the dunnage bags are used in trucks, in trailers, between the pallets, and then they inflate these bladders to snug up the pallet so there's no shifting during transport. And so they have to sonic weld a spout onto the plastic, and that does better with polypropylene than it does with polyethylene. So we were putting polypropylene in the core layer. Now I've run a lot of polypropylene film, and 19 out of 20 times we lose the bubble because polypropylene runs at a much higher heat setting than the polyethylene does, and to get everything just right, the frost line will go up or down. You'll start losing air in the blow up. But I was looking at this line, and we were talking, and I could see the polypropylene come up through in the core layer because it went really opaque. And I looked at the frost line, and that frost line didn't move an inch. I looked at the bubble diameter. That bubble diameter, it didn't sway, it didn't go up, it didn't come in, it didn't move at all.
Oh, the computer automized.
It was so impressive. And that's the benefit. If you're looking at high output products, that is really a strong consideration to look into, because that's top of the line, top shelf equipment.
Yeah, I know you talked a little bit about gauge control too, and other areas of controlling costs. Obviously, is a key factor with some of this.
Right. Okay. Well, and that's a really good point, because 2 things. Again, resin costs account for about 60 to 70% of the cost of a bag, and if you're running older equipment, typically older equipment, you're going to run a gauge variation 10 to 12%. I've seen some worse. If you can get inside of 10, 6 or 8%, that's excellent for the older machines.
Right.
But here's the deal with the older machines, and let's just say at 10% gauge variation. You want to run a 2 mil film, but you have a plus or minus tolerance that your customer will accept. And so what you have to do basically is you got to run 10% more resin into your film, so that when you get to the bottom gauge in that variation, you're still within acceptable gauge. And so you're spending up to 10% more in resin costs. With a line like what Dan was talking about, these high output, total computer feedback control, and you're under 2% gauge variation, you run a 2 mil film, you're running a 2 mil film. And that plus or minus, you're still within variation. So you're running at 10% less film. Resin right off the bat.
Well, to top that off, they've now been able to really fix the lay flat control as well. You no longer have to take that 5, 8, 10% cut off of the edge trim, because they now have flat film technology that they take virtually no edge trim. So if you add that on top of that 8 to 10% more resin that you need, and now you take the gauge variation or the lay flat variation out of that, you're now using 15% less resin. You're not having to recycle that through your process. That's money going back directly into your pocket. That's cents per pound that goes directly to you.
Right. And the reason for that is the tendency to edge wrinkle. And that occurs primarily on rotating nips. Whenever the nips rotate and it stops and comes back, normally you'll get the little glitch where you see some edge wrinkles. Or I've also seen when you rotate too fast, you get edge wrinkles. And so we've had to slow down a lot of the speeds, the rotation speeds to get. And the reason you rotate, just for the audience, is so that you can randomize any gauge variation that's in the film. So if you don't randomize, when you make a roll, then what happens, and that gauge band stays in the same place, it really contorts, and you don't have a good roll conformation. And normally that goes into the rework pile. And so you want to randomize any gauge variation by rotating something. So how did they overcome the edge wrinkling?
Well, there's a lot
situation?
of proprietary information out there.
Don't want you to say anything you're not supposed to.
Oh, come on, please.
There's a number of things that you can search online. Again, I'm going to go back to the Flex Pack Con that we have coming up through SPE coming up in another month. We're going to have people from W&H and Reifenhauser presenting their technology at that conference, and that'll be specifically addressed on how they address it. AMI's Polyethylene 2017 that was held earlier this year in Daytona Beach, there was presentations specifically focusing on the economics and how customers or converters can dramatically save on the variation in the web width as well as a variation in film thickness, exactly what you're saying. So there's lots of references out there in the marketplace. I
imagine output rates are becoming more critical too. I mean, you've got the rise of pouches that obviously the last few years have really emerged in North America as they have in other parts of the world. Has that been more critical? Cycle times, output rates of some of the equipment and some of what you're doing in a facility these days because of how much you're having to make?
A lot of that also is resin selection. We were at a customer that is running. They've got some really nice equipment, high-tech equipment, but their back pressure in amp limited. So they can only go so fast and they can't get any more out. The salesman came to me and asked, can we help him? Can we get him higher output rates? And I looked at the details of what he's doing and I said, yes, we can. We need to have him try this resin and we can get him 10, 15, 20% better output rates. And so the salesman, sold that to the customer. We went out, we did the trial, and literally at 20% higher output rate, we had lower back pressure in amps than the material he was originally using. And so we came in with less energy consumption, 20% more output rate, and with the same employees, the same overhead costs. The only variable cost was the resin, because now you're using more resin, but you're getting more finished pounds out in an hour. We literally saved the guy a lot of money. It cost him 4 cents more for the resin that we used, but he put 7 cents more in his pocket. So he paid for the 4 cents for the resin difference, plus he put 7 cents more over what he was making profit-wise before we went into the thing. And so that is a real critical key, and that is resin development, along with putting it into the equipment, because the equipment continues to get better, the resin continues to get better as well. And you can
channel that down further into the actual product that's made, and you can cherry pick which resin that you're going to need. You have to engineer and design the sealant layer that you need. That's why the new polyethylene, all polyethylene pouch is really important, because you're able to use the I-beam effect. You're able to put in the specific sealant layer that you need. If you're running a 5-layer coax, you can make it a very thin sealant layer and improve your overall economics. But yeah, I agree with you. The downspeed packaging lines, they like to run faster too.
Sure.
So the converters, the resin, so it's a team approach.
Sure, and that was sort of a question I was getting to with some of this is, you mentioned this collaboration among the machinery suppliers and the resin producers is also happening between the converters, the resin companies, the processors,
the end users.
Is that happening? It's been talked about for a long time, but you're actually seeing that taking place, at least in the upfront end, when you're still designing and putting together.
Oh, absolutely.
Product.
I know. With our company, we put almost $20 million worth of investment into a facility in Calgary, and it's designed for the end user, for the brand owner, for our direct customers to come and use our facilities to innovate. We've put in a 9-layer blown film line. We put in an adhesive laminator, a laminating line. We put in a horizontal form fill and seal machine. We put in vertical form fill and seal machine. We put in a lot of equipment for our customers to come, and our downstream customers to come and innovate at our facility. So before they have to spend all that money in trying to do field studies, they can first try it at our facility. So it saves them a huge amount of money. We put that in specifically to try to help the speed to market.
Right. And that's most of the suppliers are doing that as well, which is an industry collaborative effort to advance the science and the technology and performance of flexible packaging. Oh, and that's a great service, and we use their service too, because I'm not a stranger to their laboratories.
Excellent.
They do a great job there.
And with that sense too, we're talking about the food packaging and the consumer end. I know there's been a need to lightweight and to go smaller with down gauging. How much can you go with that? How thin can you get before there's like maybe a consumer perception that it's too flimsy or doesn't work? What kind of fine line do you reach with some of that?
A lot of that goes into, again, what the end-use application is and what the performance criteria. I'll give you one example, and this is in ice bags, the 7 and 10 pound ice bags. Typically as a 1.75 mil application. They wanted to go down to a 1.5 mil bag. We had to change the resin selection because it was on a mono line and we didn't have the advantage of using different layers to really get some even better enhancements. So with the mono line, we changed the resins and we changed the blend ratios and we got the 1.5. And not only did we get to the 1.5, but we got better sealability and we got better overall toughness in the bag. They tried that for a while. They wanted to go down even lower. They wanted to go down to 1.25. Again, we had to change the resin formulation, change the blend ratio. We went down to 1.25. However, that took it too far. We had the physical property requirements met, but the bags, whenever they go into the ice making filling station, they have little suction cups that take the bag and open it up. And the bags became too flimsy at the 1.25,
okay.
And it wouldn't open it up consistently, and so you lose product, you lose production efficiency.
And that's where you can use a 5-layer co-extruded structure. You can use the I-beam effect and stiffen up that film.
And so it depends whether you have the mono or you have the coax. With the coax, you have a lot more variability.
There's some other stuff that you see going on in the industry right now. Double bubble. For double bubble processes.
What is double bubble? Let me explain that.
Double bubble. You say that 5 times fast.
Double bubble. Yeah.
There's double bubble and double bubble.
Double bubble. It's to make biaxially oriented shrink film. IKEA is a really good example of that. If you go in an IKEA store and you buy your package and it's shrunk wrap. Mm-hmm. Okay, it used to be cardboard. There's a lot of work that changed it away from being cardboard to it's shrunk wrap. So where the state of the art is with that film right now, they're down to 30 and 32 gauge. So you translate that into mils. That's 0.3 to 0.32 mil thickness.
A third of a mil.
That's like tissue paper.
Yeah.
How low can you go? It's reaching the limits.
Yeah.
So that and that technology continues to evolve itself.
And that goes back to customer perception.
Yeah.
When you get too low a gauge or too thin or too soft and it feels flimsy, even though it could be a better performing package, the customer perception or the customer perception is that it's too flimsy.
Yeah. Are you finding pushback, Joel, on that end with customers on down gauging?
Absolutely. I really have nothing to add to what I said earlier.
Yeah.
I got a funny story though.
Sure.
I had a situation in which I worked with a customer for down gauging. And a lot of it is education. It's the education coming from the converter's perspective, it's coming from the resin producer, and from a whole bunch of different avenues. Did a lot of work, was able to take a cereal package and were able to down gauge it from 3 mils down to 2.5 mils. And using the high barrier, high density polyethylenes, etc. So went back to the customer and said, okay, here you go. We just did exactly what you wanted to do. We're able to down gauge that film. Yeah, but it costs more now. What do you mean it costs more? We took 0.5 mil out of it. Yeah, but the resins that you put into it are more expensive. What? But when you do the math, it's cheaper on a per unit basis. Well, no, but our customers buy based on the pound. So there's a lot of education that we have to do to work with our customers to convince them they're not buying based on the pound, they're buying based on the impression. And that's a sustainability challenge that we as a resin producer and equipment supplier have out in the marketplace is presenting it from that aspect of it.
We do something that I don't think anybody else does. We have a section which is, we called it handy math. It's how to get from weight to area, metric or English, and for every story like that, we have 15.
Is that one of your blogs that you have?
No, it's on the website.
Oh, I'd love to see you even do a blog, but it's on your website. That's great.
But
that is good.
But the point is that we have so many people who can't get over the unit
math.
Of measure being pound or per kilo to per package. They just can't make.
It's a perception.
They can't make that. They can't make that jump.
Yep. I'm not going to buy it because it costs more per pound.
Right. Right.
We are about out of time, and we probably open up for questions from the audience here too, and I'm sure they have some on the conversation that we've had. We want to start with one question for you guys that I'll start with anyway. I'm curious if there's anything in plastics you could change. What would that be? If there's one thing in plastics that you could change, what do you think it is? We'll go across the board here. Who wants to start? Joel.
Joel.
Perception.
Perception.
Plastics does such a great job in so many areas of our quotidian lives, and as an industry, we just expect everybody to see all the great things that we do. The problem is that for whatever reason, kids from an early age are convinced that plastic is not good. They lump it in with fossil fuels and other things. It is just something that I think we need to work on as an industry to change the perception and show all the good that it does, not just the number of jobs, but anyway, just try and live your life without plastic.
Yeah,
I got a really good example of that. I'm part of SPE's, I'm a counselor with SPE, and I'm on the board of directors for the Flexible Packaging Group. We had a board of directors meeting a few weeks ago in Detroit, and we had a representation from the Plastivan, and that's sponsored by SPE, and they go around to the schools, and the intent is to educate. Well, the teacher that was presenting to the students asked the students, well, how many here brought plastics to school today? And then you had a few kids that put up their hands, and she says, now think about it. What are you wearing? What are your shoes? What's your shirt made of? Do you have a watch with a strap on it? And it was amazing that every single one of those kids finally realized that plastic is a very important part of their life, but the perception isn't there.
Well, I think part of that perception deception is the littering that occurs across this country. And that's not a plastics thing, that's a people thing. And people can fix that. But I think the perception is that plastic gets a bad rap because they see it on the roadsides. And I think that's maybe an educational process that all of us could learn from. Don't litter. Don't litter. The other thing, from a perception standpoint, I think that we could change and enhance is, you know, we all go to school through the 12th grade, mandatory. A lot of us go to college. A lot of us don't go to college. A lot of people go to trade schools, which is phenomenal to learn a trade. I think that as an industry, we need to see more trade educational centers that teach people the different aspects, how to make a mold, how to polish a mold, how to process plastic, and things like this, to give them the education. And I think that and that's part of that perception that we need to do a better job in education.
Absolutely agree. When we had our SP meeting, we're really, really trying to address that right now. The statistics are within the next 5 to 10 years, there's going to be a 2 million people shortage in the plastics industry.
That's huge.
It's absolutely massive. The support system is not there today. And it's part of us as a culture too. We always want our kids to do better than what we did. And the perception is the 4-year degree, get a high paying job, et cetera, et cetera. That's not necessarily true. There's a really good book out there called Rich Dad, Poor Dad, written by Kawasaki. Go read that book. Yeah. Just because you got a good education doesn't mean you're going to be successful. I really like that book. Yeah.
If you can, we got a few questions in the audience I'd like to get to here in the about 10 minutes we have left with this. Question was about gauge variation. Is there gauge variation in extruded blown film? Is there limitations on this that you have to deal with? One of the people in the chat asked that there were limits on gauge variation. We want to respond to that.
I'll take that one on. What I do when I go into a customer and we want to optimize and get the best gauge variation, what we'll do is we'll stop rotating. If something's rotating, the die, the nips, whatever, we stop the rotation. And what I like to do is I get a magic marker and I put a streak on the film as it goes up. I mark that south because it's by me. Then the opposite side of the air ring I put in for north, and then obviously to the left I put west, and to the east I put or to the right I put east.
Oh, okay.
So when the stripe
pretty visual too, I guess.
Yeah, when the stripe comes down,
then
what we do is we cut it right on the mark that I made. And so the mark, when we stretch it out, both ends are south. Right in the middle is north, and over here is west, and over here halfway is east. And then we mic it about every inch. And we look and see where the gauge variation is. Then from that, we get the information of where the gauge information is, and then we can go now to the die, because we've marked it north, south, east, and west, and we have adjusting bolts down at the bottom of the die. We know which adjusting bolts to loosen and to tighten. We could do that. Normally, we can improve it by about 10 or 12% the first pass. We put it back on, we let it go, and we do the same thing. We repeat. After about the third time, we get the best gauge uniformity that's available on that extruder.
Or today you can go out and buy a brand new line and it's all done automatically for you.
Or you could buy a $2 to $4 million
You might
line
want to invest in that, I guess.
and do it automatically.
Joel, you
But
seeing
hey, the
anything in that area
payback's there.
too?
The payback is
Well,
there very quickly.
I'm dating myself, but back during John Kennedy's first administration, we used to use Crayolas to do what
Crayolas,
they would melt, and that's how you went about adjusting your die. Skip ahead to the 70s and 80s, and we had non-adjustable dies and non-adjustable air rings. People ask me all the time, well, what kind of equipment do you have? And my answer to that is, when you look at a 737, which is 18 years old, there's not a lot of original parts left. And this gets back to what we're talking about, how difficult it is to get help, that making blown film is an art. And it takes literally years to really get good at it, and you really, it's a self-sacrificing art. I don't mean to get lofty here, but you make it today and it's gone tomorrow. You know? And so you have to get people interested and really wanting to be a good craftsman.
Yeah, and that goes back to when you're talking about training. There's more excitement. You think it's not just a routine, programmatic kind of thing. It's something with art to it, right?
Yeah.
Right.
Well,
And
it's having the passion.
Yeah.
And it's going after the details, because the devil's in the details.
Right. And when we have new hires, we try to tell them all the good things that plastics does. It's like, okay, this is going to go into a surgical drape. This is going to go into an ostomy bag. You know, you really need to make sure everything's really clean there, or it's going to do this or this, all these other things.
Sorry, had to throw that in.
Absolutely. A question here about the all PE bags that we were talking about and that material. Are there global regulatory issues of concern when you're doing a mono-material type of construction, like a PE, like an all PE film or a pouch or whatever it happens to be anyway, bag?
Yeah, that's a really good question. Again, that comes back to the circular economy. And how can you most effectively do that? I know with our corporation, we've taken a leadership role in a lot of organizations, in the Sustainable Packaging Association, the CPI up in Canada, in terms of how to effectively handle the recycling stream. That's a real challenge. Is it legislated that you have to have a blue box and that your community has to pick it up? Or how do we have more effective recycling as it occurs? I remember going into a major automotive company a couple weeks ago and did a tour. I had a PET water bottle and they advertised as being green and sustainable. I couldn't find a recycling box. That blew me away. So really? It is. It's a system.
But back to the question, what they're doing is they're making it easier, because the #1 issue confronting the recycling industry is cross-contamination. And when you start with a 7, you've got a problem child to begin with. Right. With what you guys are doing, it's all PE.
Right, but how is it going to get out there? Does it have to be legislated in, or are people going to voluntarily pay more to have their curbside pickup done? I know in Canada, it's part of our tax system. Your blue box is there. If they find that you put recyclable materials into your garbage, they're not going to pick it up. You got to put it in your blue box. It's legislated in that each community has that. Now, is that what it's going to take in the United States for it to go cross country? I don't know. Is that the best solution? No. There's other ways to do it. You have waste to energy, you have sustainability reduction, there's so many different ways that you can do it.
Okay, but we've done our job. If you get it to where it's all #4 or all #2, you don't just start out with a #7, and there's more incentive for the recycler to recycle the same polymer, and that's where you get into all the sorting and all that.
Right.
And speaking of which, I know we talked a little bit about recycling. I know it's an issue how to recycle end products like pouches. there are other advantages, environmental advantages, if you look at the whole product and the total cost of operations and everything else. If you look at everything that goes into it environmentally, I imagine it's more than just whether you can recycle the pouches or not. Is that correct?
Yeah, you have to make sure that the package is totally cleaned out inside. I know there's a lot of work.
Well, I guess I'm thinking about energy reduction and some other areas
well, the energy reduction comes into, again, a lot of it is resin choice. You look at the metallocenes. We didn't talk a whole lot about metallocenes, but with metallocenes it allows maximum amount of down gaugeability because you increase strength properties, seal properties extremely high, and that allows you to down gauge. So there's less material going in, and consequently there's less material that you have to deal with. And so that's one aspect of this whole how do we recycle it thing. We reduce it as much as we can.
Right. How do you be sustainable, I guess is the question.
How do you be sustainable? And so a lot of it, again, is working with your supplier, your distributor, looking at the applications, and working in collaboration with people like us to select the right materials on a given piece of equipment to get the very best and the least amount of gauge. Again, because we're cutting cost, we're making packaging more affordable because we're reducing cost, and then there's less to recycle.
Yeah.
But then having the things that you do recycle, if it's all a given class of plastics, it's easier to recycle.
Right, sure.
Than the number 7 when you have mixed polymers and it basically goes to landfill.
Or waste, or developing waste energy technology.
Waste energy
How's that?
technology.
I should ask about that. We didn't talk about that a whole lot. I know there have been things like Dow and others have done waste to energy facilities. How is that going? Is that technology still a little bit far away to do, at least in North America, to do that type of thing?
Yeah, that's a challenge in North America. I think you see a lot more prevalence of it in Europe than you do in North America.
Is it being successful in Europe? Is it working in Europe?
We'd have to take a look at the numbers to see. I'm not totally familiar with that.
I think, and I'm not an expert by any stretch, but I think there's more pressure in Europe and particularly in the Far East because of land restrictions and population per square mile. They have to address it a lot more intensely than we do in this country.
We have more landfill space, in other words, right?
I think we're still at a cost thing. If it costs too much to do it, we're not willing, as a people, we're not willing to put out the dollars. When it comes to the point where the cost of it outweighs the benefit of having to recycle it, then I think it'll be a unanimous choice for most of us, population-wise, to go and to do those recycling techniques. But as long as it's more expensive to do those types of things, it's going to have a lot more resistance. We like to talk about it, but when the rubber meets the road, it's all about dollars and cents. And right now, the dollars and cents, it's easier to throw it away than it is to recycle, and that's where we're at today.
We're kind of dancing around the issue, which is that the greenest raw material you can use is the one you don't use. And source reduction is incontrovertibly the best way to go. But for some reason, that's too abstract for most consumers, and that's why there's so much emphasis on recycled content. And recycled content does not work for an awful lot of things, like medical, for example.
But keep in mind, with food packaging, 50% of what people take home is thrown into the garbage. So with the advancements in flexible food packaging, we're taking a direct hit at that to reduce it as much as possible.
Okay, one more good thing we do.
Right. Well, I'm going to cut it off there. We've cut it off on a good thing, right? That's a good way to end. I want to thank our distinguished group of flexible packaging and film extrusion experts today for their lively and informative discussion. Rudy Bourgeois of Holland Company, Joel Longstreth of Brentwood Plastics, and Dan Falla of Nova Chemicals. You guys were great, and we covered a lot of ground today, a lot of rich area of conversation that could go on for a lot longer than the time allotted, obviously, right?
Certainly could.
We also appreciate your attendance at this Fireside Chat, fueled by Holland and produced by Plastics News. If you want to revisit this chat, the entire event will be archived on the live stream webinar section of plasticsnews.com. Finally, make certain to set your calendars to join us at the last in our series of Fireside Chats in October. Be on the lookout for more details about that event. Thank you for joining us today, and we'll see you at a future Fireside Chat.